Hello everybody, how's it going? I have a problem for you today, a problem. It says find I1, I2, I3, R1, R2, and R3. Those are the currents and resistances. And find the power dissipated and the voltage consumed. So we're trying to solve for I1, which is down here. I'll back out tiny bit so you can see it. I1 is here, I2 is here, I3 is here, and R1 is R1 is right here, R3 is here, and is R2 is this one. All right. The first thing to do when you work on this problem is to realize that the current in a circuit, the total amount of current is always constant. It's not something that's increasing or decreasing. So if we have 26.53 milliamps in this branch, and this doesn't split or have any junctions between here and here, I'm talking about I1 here and up here. So that means we know I1 is going to be 26.53. Current can split off and flow to other places, but it's going to be the same throughout. If you add it all up, it'll always be the same. So that's I1. R2, the next rule about circuits and electricity we use is that the voltage drop across parallel circuits or parallel branches is the same. So for R2, we can say V1 is equal to V2, and then I1, R1 is equal to I2, R2. Solve for R2 and plug in the numbers, and you get 10.07 milliamps for the denominator and 1500 ohms times 5.03 milliamps. When you put that to your calculator, you should come out with 749 ohms. There we go. I2 might look tricky at first, that's this one right here, but all you have to do is realize that you have a parallel branch that splits, like a junction that splits into multiple branches, but that same branch leads to another parallel branch. Those parallel branches will still have the same potential drop across them because parallel has the same, but if that parallel branch has more parallel branches, they're still parallel. You can tell by looking the branches here and then branches again, so you know that's the same. So solve for that the same way. I2 R2 is equal to we can just plug those numbers in right away. It's 1500 ohms times 5.03 milliamps. Okay. And then just take R2, move that over to here, and then plug in 900 ohms. And when you do that calculation, you should get 8.38. 8.38 milliamps. So I'm going to take that and this. I'm gonna move this down a little bit. Store that up here. Don't forget the I2. Get back up there. There we go. Okay, moving on. We need to find I3. I3 is a little more tricky because it's you're trying to find that, but you have other resistors that are connected to it. But if we apply the same logic, we know resistors in series, you just regular addition. Resistors in parallel, you have to do reciprocal addition. So in our case, all we have to do is say we have the 650 ohm plus R3 plus the 1250 ohm. And then the current for that is between I2 and I3, they have to have the same current, so we know that will be 8.38 milliamps. And this is equal to, we can set this equal to 1500 times 5.03. But we've done that product a few times already, so I'm just gonna go ahead and put 7,545. And this is, oh yeah. So I'm gonna solve for R3, just do some algebra. We're gonna have 7,545 up here. Over 8.38 milliamps. Minus 650 minus 1250. So we get R3 is equal to you get 1,000 ohms. Alright. So it looks like we've solved for just about everything so far. I'll write this up there. We have I1, I2, R3, R2, R1. Didn't we solve for R1 already? R1 was supposed to be let me see what happened to R1. 3, 2. Alright, there is no R1, we don't want to solve for it. So now that we have all those, we need to know the equivalent resistance so that we can find the voltage consumed and power dissipated. We start by adding together all the resistances. So we have, I'm going to do this one slightly differently. So we have the 900 ohm connected in series to, and when they're connected in series, that's how we know to do this regular addition. So 1/49 plus 1/1500 and then alright, I'm going to upload part 2 later. Have a good day.